Okay, so my name is Matthias Baudot. I'll introduce myself a little bit later. I'll start with our giant are female. I choose Farah Alibé. She's just my age, 35. She was born in Montreal, and I live in Quebec City, close to Montreal. She speaks French, and that's probably all what we have in common. Farah Alibé, you probably all heard about Perseverance rover from the NASA, who landed on Mars at the beginning of last year. Farah's job was to make sure that the robot doesn't get lost on Mars. So on Mars, you don't have Google Maps, no maps, no GPS, no compass. The only way you have to get the position of the rover is to use the time and the position of the sun that you can observe, like the first explorers. So right after Perseverance landed, our role was to determine the position of the rover and its orientation with respect to the Earth, so she could point the antennas toward the Earth and start communicating properly. So I choose Farah. I hope maybe we have some young people, young women joining us today. I found it's very, very inspiring for young people starting to get interest into technology and science. As long as you work really hard, everything is possible. So I found her very inspiring. So let's continue with the presentation. All you wanted to know about LabVIEW and Web Services, but fear to ask, part 2. This is part 2 because this presentation was divided into 2 different presentations. Part 1 was given at GDEFCON in Amsterdam in September of this year. And part 2 is today at the GLA Summit. Part 1 was basically at GDEFCON, the audience chose between 2 topics, integrating existing web services in your LabVIEW application, so using LabVIEW as a client for existing web services, or implementing your own LabVIEW web services for other developers, maybe in other programming languages. And at Amsterdam, the audience chose to hear about the server part, implementing your own LabVIEW web services. So that was part 1. And today is part 2, where we will focus more on calling existing web services from your LabVIEW application. There is a poll that was just published. If you hover on your right screen, you have several tabs. In the session tab, you have chat, polls, people, Q&A. So if you can answer the poll, that will help me to target a little bit the presentation. Also, if you have any questions during the presentation, feel free to ask them in the chat. I'll try to monitor the chat as good as I can. Again, post in the chat for the session, not the event. So you need to have the session tab selected in the top right of your screen. On your screen right now, you can see the bit.ly URLs for the 2 presentations. The recording of the part 1 is already available, also with the slides, and the part 2 will be posted very soon. Okay, a quick introduction about myself. So I have a master's degree in electrical and computer engineering with a specialization in advanced signal processing and neurosciences. I've been doing LabVIEW for more than 15 years. I love LabVIEW. I felt in love with LabVIEW at university, and that was an amazing discovery. So LabVIEW is my main and almost only programming language. I'm a LabVIEW champion and certified professional instructor. I'm also a member of the board of directors of the DQMH consortium, well known for its DQMH framework. In 2015, I won the competition of the world's fastest LabVIEW programmer. That was fun. Other than LabVIEW, I like to do guitar, piano, drum, windsurf, snowboard, And I founded my company StudioBuds in 2007. StudioBuds is an NI consultant partner, also a member of the DQMH Trusted Advisors. We offer to our customers LabVIEW development, consulting. We do a lot of consulting, code reviews, architecture reviews, continuous integration. And of course, we also give various trainings, NI trainings and custom trainings. The company is based in Quebec City, in Canada, and a new branch will open beginning of next year in France as well. StudioBuds also has some tools on the NI tools networks. The most famous tools is BLT for LabVIEW. It's a toolbox that allows LabVIEW developers to build, license, and track their LabVIEW applications with just a few clicks. That's from far the easiest and fastest way to go from a simple LabVIEW app to a deployed license application with automatic update capabilities and many more features. So if it's the first time you hear about it, I strongly advise you to go check it out and try it out. It's been around for more than 10 years now. Another tool that we have on the NI Tools network, it's controls generator for LabVIEW. It allows you to create LabVIEW controls .ctl file from pictures with some recoloration, color detection and recoloration features. Okay, that's all for the presentation, introduction, advertisements. Now let's dive into the topic. So I'll start with some web services basics, and just to so we have all some initial knowledge to continue. Then I'll show you some examples of how and why you would call existing web services from your LabVIEW application. If you are interested to get some tips, tricks to implement your own LabVIEW web services, learn all what I've learned in the past years writing large LabVIEW web services applications, you can definitely check out the presentation I gave at GDevCon, which is the first part of this presentation. And I'll finish with some useful tips and resources if you are dealing with web services and LabVIEW. So what is a web service? A web service, it's any application, software, cloud technology that provides a standardized web protocol to interoperate, communicate, exchange data messaging through the internet. So to summarize, it's an application to application communication and interfacing. The nice thing is that applications can be written in various languages and they are still able to communicate via web service between them. The idea is that you have a client, a web service, the client make a request to the web service is going to process the request and send back the response to the client. That's what is a web service. There are various types of web services. This list is not exhaustive, just maybe the most commons. We have the XML RPC, basically based on XML protocol over HTTP. You have SWAP, also uses XML, generally over HTTP or SMTP. gRPC, you probably heard a lot about gRPC recently because it's getting integrated natively into LabVIEW. It uses protocol buffers, kind of similar to XML, but faster over HTTP. We have REST, representational state transfer. It uses XML or JSON, mostly over HTTP. And today we are going to focus on REST web services. So REST means representational state transfer. State in this situation means the data. Representational means the format that you're going to use to transfer the data, such as XML, JSON, HTML, whatever. And transfer is the mechanism that allows you to carry the data between the consumer and the provider, the client and the server, the web service, using HTTP protocol. You have four architectural constraints to basically tell that an API is a REST API. Identification of resource. To do that, basically a REST API, the resource that you are able to manipulate are identified with a unique identifier that should clearly give an idea of what data, what collection of data you are manipulating. Manipulation of resource, that means that you can create resource, delete, modify resources through a web service. Self-descriptive message means that the API is kind of self-documented by itself. When you get an error, you should have a description and a reason of the error. And it is intended to be a stateless protocol, which means that when you're making a request to a web service, the web service should not know what you've done before. Each request should have everything needed, should have everything needed for that request to be processed. So web services that adhere to these 4 constraints are called RESTful APIs. So the REST architecture, it's very straightforward. You have, again, a client and a server. So the service provider is a server. It's a web server because the transfer mechanism is HTTP and it contains a REST API. And the client can be a mobile application, a desktop application, or a web application. So that client make an HTTP request on the server. The REST API is probably going to talk to a database where the data is stored, and then send the response through HTTP back to the client. And we are using a messaging format, which can be JSON or XML or other format. JSON is probably the most popular as of today for REST web services. So the different components of HTTP-based RESTful API, a base URI. So for instance, http://api.example.com. That's the base URI where the web services are hosted. Then you'll have endpoints. Endpoints, it's a reference to a resource, a collection of data. And an API may contain multiple endpoints, of course. I'll show an example shortly. And to communicate with your API, you're going to use a standard HTTP method. Here are the 4 most used HTTP methods in RESTful APIs: get, post, put, delete. You also have patch options, some others. But here are the 4 most used methods. So get allows you to get the representation of the resources state or resource data. Post, let the target resource process what you've sent through the request. Put allows you, should be intended to create or replace the state, the data of the resource on the server, and delete makes sense by itself. So an example is the Paymo API documentation that I'll show you right away. Okay. So Paymo is a project management software that I really love. It's similar to Jira. Maybe you use Jira. There are some others, Asana, a lot of project management software, but I like Paymo very much. This is the documentation of the Paymo API, which is a RESTful API, as it is stated here. So the documentation is really the most important thing when you want to integrate web services to your LabVIEW application. You need to read this documentation very carefully. Here in the table of contents, we can see how to make a request, how to authenticate, etc., and all the API endpoints. So for example, you're going to have endpoints to manage your clients, your company, your expenses, create invoices, projects, tasks, task lists, time entries, users. All those are expensive, endpoints. And if I click on a specific endpoint, it's going to tell you which method you need to use to get clients, create a client, updating a client. For example, getting a client, you're going to make a get request, where if I choose to update a client, it's going to be a post or a put. This API accept both. So this is very important to be familiar with that terminology, and to spend time reading the documentation of the API you are consuming. So let's see an example how it looks in LabVIEW. So here we have our URI, and we add to the URI collection that makes the URL. And if we do a get, HTTP get to that URL, we are going to retrieve the list of identifiers that are members of the collection. So in the body, you're going to get an array of JSON elements that are the members of your collection. Now, if you add at the end of the URL item1, api.example.com/collection.item1, you're going to get the representation of the of item1 specifically. So you get a JSON object with the different elements that makes the item1 representation. Let's do the same with a put. If I do a put to this URL, the collection, it's going to create the collection resource if it doesn't exist. And then, of course, since it's just been created, return an array, an empty array, because that collection is just new and doesn't contain anything. If you do a put to collection/item1, you're going to create or update the representation of item1. So in the body, you're going to pass the representation of item1, its values, in the request body to update item1. Something that is very important with web services are the headers. If you look at the HTTP client palette that you all have in LabVIEW, I mentioned about the get, put, post, delete. If you look at these VIs, they all return headers. This is how a header looks like. It has the version of the protocol, a number, a description, some other metadata. And you can see this number is bold. 200 is the status code of the that the server sent to the client when the client made that request. This is another example of a header that contains status code 401, which means that you are not authorized to call this request. Maybe you need to log in first. Status code is very important part of web services. This is like the error cluster in LabVIEW. The status codes are divided into 5 categories. You can get more information about that on Wikipedia. Just type HTTP status code. The informational response starts with 1. Success response starts with 2. If the client needs to be redirected, start with 3. If there was an error in the client request, the status code will start with 4. And if there was an error while processing your request on the server side, the status code starts with 5. Some examples of maybe the most used status codes that you might encounter: 200, okay, no error. 404, page not found, resource not found. You probably all experienced this one. And 500 is kind of the generic internal server error, where if you get that, you might need to ask the administrator of the web service to look into the internal logs to know what happened, unless more information was provided in the body of the reply, maybe. So that's the web services basics. Again, client, server, we make a request using a message exchange format, and we get a response back. LabVIEW can play a role in the desktop application. So you can write client application for desktop using LabVIEW. You can write LabVIEW Web Services, write a REST API using LabVIEW. That's the other part of the application that I gave at GDevCon. You can also use NIG development software, previously called NXG Web Module, to implement a web application that will also consume some existing web services, or maybe consume your own LabVIEW Web Services. And today, this presentation is going to focus on consuming an existing web services from your LabVIEW desktop application. I would say that the most tricky part when writing LabVIEW applications that deal with web services is the authentication. The authentication is the most difficult part. And once you got the authentication working, as you saw on the PEMO API documentation, it's very straightforward. You do get post put delete on some URLs, and you usually format your data or unflatten your data using JSON. So that's more straightforward. But the authentication part can be more difficult, especially these days with a lot more cybersecurity concerns. There are a lot. The authentication mechanism can get more and more complex. So I'm going to start giving an example of the authentication using an API key. And we're going to do that through Google Maps API. Let's start that. Okay. So if you go to console.cloud.google.com, you can have access to all the Google Cloud APIs. There are tons of APIs available here. In the example of today, we are going to enable the Google Maps API, the Google Geolocation API from Google Maps. So you go to Maps, and then you have all the Google Maps API, and I'm going to click to the Geolocation API and enable that API. So Google wants you to be authenticated to use their APIs. That's how they can invoice you if you make a high usage of their API. And if it's also related to some private data like Google Workspace, that's also you can authenticate. So when you enable that API, it's going to generate an API key. That's your authentication token that you need to send with every request to Google Cloud RESTful Web Services. As I said previously, the documentation is very important. So you need to know how this works. How can I use the geolocation API? So you go in the search bar, you type geolocation API, you have obviously a documentation tab, and you can open the documentation where everything will be explained. So first, we tell you, okay, what is this API? Returns the location and accuracy radius based on information about cell towers and the Wi-Fi nodes. Okay, geolocation requests are sent using POST. So you only do POST requests to that URL, and you saw that the URL contained the API key. And the reply that the API sent, the response, is a JSON formatted response that contains the location, latitude, longitude, and the accuracy. So it gives you all the information. You need to make a post to a specific URL using your API key, and you get this type of JSON response. And the documentation also gives you some information of the possible errors that you might encounter. So how do I do that from LabVIEW? How do I get my geolocation? There is a really nice toolkit, open source, free by JKI. It's called the JKI HTTP REST client. If you start from scratch, I really recommend you using that library, that package. It's very well done, very convenient. It does, for example, parsing the header string to find out the status code. All that is done with this toolkit. I personally use my own libraries mainly because I implemented them before this toolkit came out. But this one is really good. I really recommend it. Let's look at some LabVIEW code now. Google Maps API get current location. So you can see that I need to put my Google API key, and I'm going to initialize a connection to my REST API, giving the URL that was given to me in the documentation. The method is geolocate, and I need to pass the API key as an attribute in the URL. They told me to use a post method. There is no request body, so I just put an empty string. And the response body, as you can see here, it's a JSON string. And I can use here unflatten from JSON to finally get a nice cluster with my location and accuracy. For simplicity here, I use the native JSON parsing primitive from LabVIEW, but you might want to use other JSON libraries available on VIPM, such as the one from Dr. James Powell, which I highly recommend and use in all my projects. So this is an example to get current location. If you were to implement this by yourself without using Google services, good luck with that. Fortunately, there is an API available, and if you use it reasonably, I'm not sure about the rate, but it's like 100 or 1,000 calls per day. It's free to use. Now let's do something a little bit more complex. I want to get the information as I would get them from Google Maps. So for example, if I type studio boards in Google Maps, you're going to get the address of the company and the phone number. So to do that, I use the place API of Google Maps, and I send a text search query sending my keywords and also the Google API key as an attribute. I send it as a post, and I will get a JSON string that is an array of results and some status. I assume the result I want is the first one, so I will index the results array and get from that the place ID. And then I use another endpoint, which is details, to get the details of this place ID. And I'm going to get in the response the address, international phone number, the URL in Google Maps that you can use directly to drive to my company, for instance. So that's another example of using Google Maps API and the geolocation API using the API key authentication mechanism. Basic authentication, it's started to be deprecated more and more because it's not as secure as some more recent authentication mechanism, but it's still widely used. For instance, Jira REST API use a combination of API key and basic authentication. It's very straightforward. In order to use the basic authentication, you need to construct an HTTP header called authorization. And in that header, you'll put basic space, your username, colon, password, and you encode that into a base 64 string that you concatenate after the basic space. So that's how you send a header through the server to authenticate yourself using basic authentication. There is not much more to say about basic authentication. I'm giving you this piece of code that you can obviously reuse if you need to talk to an API that implements basic authentication. Now let's talk about open authentication 2.0. There is also 2.1 that is getting rolled out in more and more APIs out there. This one is a little bit more complex. So you have your application and you want to authenticate your application against the service provider, so you can use their API. So the service provider, when they implement open authentication, they will have an authorization server, authentication server, authorization server, and a resource server. And you want to reach through the resource server to manage resources, get resources, update resources, etc. So your app is going to send an authorization request. That authorization request, it's basically showing up, opening a URL in your web browser where you're gonna have as a user to log in and give consent to your application to access your data. So you probably also this kind of pop-ups once in your life where Microsoft or Google or whatever asks your permission for your application or an application that you downloaded on your mobile phone, for example, to access some data. Okay, so that's what happens when my application sends an authorization request to the authorization server. I'm going to have to log in and give consent. And the authorization server is going to send an authorization grant. So to explain that once again, when I send the authorization request, I open a web browser page where I need to log in and give consent. While I'm doing that, my application is waiting for the authorization server to send back the authorization grant because I need that authorization grant for subsequent request queries. So my application is waiting. I mentioned that because I'll show you how to implement that later in your LabVIEW code, how to wait for the authorization grant. And you basically need to kind of open a little web server so the authorization server can send a query to your app through that web server to send your authorization grant. Once you have that authorization grant, you exchange it to get an access token. So you send back that authorization grant to the authorization server, and it's going to return an access token. And then you can send that access token to the resource server, which will give you back the protected resource that you want to access. I use my own library again for open authentication, again, because I implemented it before anything else came out. But if you start from scratch, I highly recommend the OAuth 2.0 G open source project for LabVIEW. And it is available again for free open source on the IPM. It already provides examples to do the open authentication for Google, for LinkedIn, for Twitter, I believe, GitLab. So I highly recommend to try this out first. So remember, I told you while your application is waiting for you to log in on the web browser, you need to open a little web server. So you will be able to download this presentation later and grab that code. You basically need to open a TCP listener and have a loop that reads through the TCP port, etc. And then you're going to get out the headers and the body. And depending on which web service you're using, it's going to send the authorization grant either in the header or in the body. So that piece of code can be very useful for you if you want to implement your own open authentication authorization mechanism. Quick demo about that. I'm going to show you how to add a calendar event to your Microsoft 365 calendar using the Microsoft Graph API. Microsoft Graph API, it's a huge API by Microsoft that allows you to do pretty much anything you want in your Microsoft 365 subscription. So you could tell, oh, I know how to create a calendar event in Outlook using ActiveX, for example. Yes, but in this case, we want to add an event on the server side. So when I add this event using the Graph API, it's going to propagate automatically on all my devices that are connected to my Microsoft account. So my Outlook on my computer, on my cell phone, etc. So here I'm on Outlook on the web, looking at my calendar on September 10. I'm logged in as Matthias Baudot. And this is the code that I'm going to use to add a calendar event. So I'm gonna request the authorization. I'm gonna get the resource myself just to make sure it's me who is logged in, show my display name and my email address. I'm gonna list the calendars, search for the calendar name calendar, and create an event right there. So here it asks me to log in. So I select my account, I enter my password. I already gave the consent, so you're not going to see that pop up in that video. So now I'm logged in. While I was logged in, the request authorization VI was waiting. At least I list the calendars, search for the calendar name calendar, get the ID, and then I create an event, breakfast with LabVIEW friends from 9 to 11. And now immediately on Outlook for the web, I get my event with the notes that I've put from my LabVIEW code, the right time, etc. So that's an example on how to use a web service API that uses open authentication mechanism. And you can do a lot of stuff with that. Okay, so that's all what I have to share regarding integrating existing web services into your LabVIEW application. Just gave a few examples. Now I'm going to switch to some useful tips and resources that are valid pretty much both from integrating web services from your LabVIEW application as a client or creating your own LabVIEW web services. So first, to test and debug this, you should use Postman. Postman is a very great tool. It's awesome. It's like, you know, when you get a new piece of hardware from an eye, you plug it on your computer, you never really start by writing LabVIEW code. You go to NIMAX and you do some basic tests. You go to the test panels. Thank you, Enrique, for posting the links in the chat. So Postman, it's the same. You, before writing any LabVIEW code to talk to the web service you want to use, you should first go to Postman and see if it works there. So from Postman, you can do get, post, put, delete, all the methods you need. You can put whatever you need in the body. You also have some authentication mechanism that are already that you can use from there. All the information about the headers, the cookie. You can have some variables, etc., etc. So this is really a great tool that I highly encourage you to use before you write any LabVIEW code. Same thing when I create LabVIEW Web Services application. My first user of the web service application is Postman. I implement the entire API into Postman, and I can save it into my Postman account and get back to it later for debugging. Documentation. This tip is more if you are writing your own LabVIEW Web Services, but a lot of public web services available out there with swagger.io for their documentation. So users, developers using web services APIs are familiar with this kind of way of showing documentation for web services. So Swagger editor basically allows you to convert textual syntax into a web page where you have the documentation of the API, and you can even try it out from the web browser if this is correctly implemented. When you do web services, you're going to do plenty of JSON. So a JSON string is not, it's not always very nice to see when it's a raw string like that. Even though here we have a pretty string, at least we have the some tabs and alignment set up. But I prefer having a view like that where I can see the nested structure of my objects in the JSON string and the data type, the values, etc. So I like this online JSON viewer. There are others that you might like more, but definitely using a JSON viewer when you look at the documentation, when you basically make a request to a web service, you get JSON reply, and the first thing I do is pass that JSON string into the JSON viewer so I can see what's in there and just maybe extract what I care about. Microsoft Graph will, I'm answering a question from the chat, it will work with Microsoft Teams. Yes, I never implemented anything specifically with Teams, but Teams is part of Microsoft 365. So that works. I had some very corner cases, use case where nothing was available in the Microsoft Graph API, especially for creating group of contacts like mailing lists and assigning existing contacts from your Office 365 subscription to contacts list. For that, I had to use Azure PowerShell. I mean, it was not fun to start with, but after doing the basic understanding, that was finally straightforward. That's so far the only use case where Microsoft Graph API didn't work for my needs or my customers' needs. But yeah, Microsoft Teams is part of the Microsoft Graph API. Next tip is Zapier. Zapier, there are other things similar to Zapier, like IFTTT, if this, then do that. Zapier, it's an alternative to this. I really like Zapier. Zapier allows you to connect to tons of web services, cloud services. You can see in the logos, you have Slack, LinkedIn, Google, YouTube, Facebook. There are a lot. And Zapier can also integrate with your LabVIEW application. I made some fun projects with that. The way Zapier works is basically you specify a trigger, and based on that trigger, you set an action or a set of actions. So for example, you connect Zapier to Jira, to your Jira instance, and you're going to specify a trigger, a new project has been created. So whenever a new project is created in your Jira by one of your manager, team member, or even yourself, it's going to trigger a zap in Zapier. And that zap is a set of actions. So an action can be call a URL. So if you implement LabVIEW Web Services, that's how you can connect Zapier to LabVIEW, by calling your web service as a URL from Zapier. And then when a new project has been created in Jira, you can, for example, call a web services that will create a new Git repository in your GitLab instance, create the LabVIEW project with the right project name, do some README editing, etc., etc. You can script a lot of actions. And the nice thing with Zapier is that you didn't have to write any code to connect to Jira or to connect to Google or to connect to Facebook or whatever, because the integration is already there. There is a free version of Zapier, but then if you want to use it more heavily, you have to pay. Web services are everywhere. Okay, there are plenty, tons of web services. So whenever you want to do something that seems crazy, first search for existing web services. If you want to write a language translator in LabVIEW, no, don't do that. You can use Google Translate out of the box and send requests to Google Cloud Services to do that. BLT for LabVIEW also has some web services, so you can programmatically create licenses. Your TV will have some web services, so you can change the channel, turn on, turn off, whatever. So there are tons of web services out there. So make sure to search for them. If you have ideas of useful web services that you find useful in your career that you are not seeing here, feel free to post them in the chat. Might be useful for others. So that's all for this presentation. I'm giving again, in case you didn't took them in notes, but they are also in the chat, the links for the part 1 of this presentation on web services server. And now we have some time for questions or comments if you have some. Thank you very much. Thank you, Mathieu. So not so many questions at the moment. So either I was boring, either you understood everything. um, thank you, Enrique. So thanks to all for your attention. I hope this was useful. You have my contact information. I'm also on NI forums. I'll put my pseudo right there on the chat if you want to reach out to me. Have you done much with gRPC? No, I didn't do much with gRPC. You know, just what I was able to see from various NI presentations and some internal presentations from NI. I'm kind of familiar with the concept, but never used it in real projects. Also, I didn't say when I introduced myself that even though I have a background in electrical and computer engineering, I don't like hardware very much. So what I do is usually doesn't really require a high throughput, high data streaming. So I never really got the need for gRPC, which I believe addresses one of these drawbacks of REST web services. REST web services, it's really synchronous stuff. It's not meant to get high data throughput. So no, not much more with gRPC. Glad it was helpful. I'm also put another link on the chat to all my presentation. I gave some related presentations in the past, one called Write Web Applications Entirely with LabVIEW. This presentation also showcases how to write your own LabVIEW web services, so then you can implement your front end using GWeb development and have a web application that communicates to your LabVIEW web services and create really nice web applications. I've done some cool stuff. For instance, I created a web applications for my customers where they can log in and see all the projects, the tasks, the time entries where I worked on for their projects. This basically web application uses the Paymo API because I'm using Paymo as a project management tool. So when the user logs in into the web applications that I wrote using GWeb development entirely in G, it's using the Paymo API to get the projects for that specific customer and list the various tasks, and the customer can monitor the budget that was spent, create new tasks for me, had some comments and some files, etc. So that was some of this application. Chris wants to know where you're coming to Melbourne, Australia. When you're coming to, I would love to do that. I've never been to this part of the world. So I know that you are trying to put together a GDevCon conference in Australia. Maybe that will be the occasion. Also, as some of you know, I'm moving from Canada to France soon, so I will be closer to you, Chris. So definitely in my to-do list, I would love to visit Australia. I heard many times it's a beautiful country. So I'll definitely stay tuned for more information on the GDevCon, and that might be the good occasion for me to come visit you guys. Good night for the French audience. Okay, so I'll stop sharing and I'll stick into the chat for 8 more minutes. If you have questions, you can continue to post them on the chat, or feel free to reach out to me via email or NI forums or Twitter. If you have further questions, thank you very much and enjoy the rest of the conference. And I should not have forgotten that, but I forgot to do it at the beginning. Big, huge thank you to all the organizers of this event. This is an amazing event. I'm sure it requires a lot of work. So kudos to everyone in the organization team for bringing all this together. Thank you for your devotion and your dedication to the LabVIEW community. That's really great. Thank you very much. Have a great end of the conference, everyone. Bye-bye.